Thanks. Hello, everyone. Welcome to the October edition of the Cloud Foundry Community Advisory Board Call. It's a pleasure having everybody here today. It's a special month, this one. So, as some of you have probably heard, the Cloud Foundry Day event is scheduled to happen ahead of KubeCon this year. So, it starts next week. It's a single day event. So we have a lot of fun talks prepared for that. It's a good mix of Bosch, newer projects like Queryfee, Paketo, some community updates, and all of that fun stuff. I would encourage everybody to register. It's free to attend virtually. So, excuse me. So you can, join us from wherever you are. All of the talks will be streamed. Obviously, the talks are also going to be available on YouTube right after, but it would be fun to have folks register and attend virtually. So the big demo for today's call is going to be about Interoperator. A reason I'm excited about this topic is Interoperator is designed to bridge between the Cloud Foundry world and the Kubernetes and services world. Services is obviously like a big ticket item here for the foundation and in the Cloud Foundry community generally. It's got like, obviously a very important position architecturally and engineering wise. The Open Service Broker API project, which the foundation also helps govern, is again like a big piece of what we do here. So what the demo today is going to showcase is Interoperator, which basically bridges this gap between services and Cloud Foundry and Kubernetes and things like that. Doing the demo today are Anoop and Jintu. So welcome both of you. Anoop and Jintu are both part of the SAP BTP team. So the SAP Business Technology Platform team. They're both based out of the Bangalore office, and they're active contributors to Service Fabric, Interoperator, and all of these wonderful tools that we make use of. So Anoop, Jintu, you guys want to kick this off?
Yeah, sure. Thank you for the intro. And so today we are planning to have a demo for Interoperator. So our idea is to have a high-level architecture view about, like high-level overview about what is Interoperator is all about, and going through multiple scenarios, and then we will take you through a demo, and then we can open up for a Q&A section. That's what today's agenda is. So I will share my screen. Just a minute, I have some issue with sharing my screen. Just a minute.
Yeah, I think happens sometimes when we update Zoom. Happened to me.
You have to pray to the Zoom gods and the demo gods for any of this. So. So while you're getting set up, maybe I can just fill the silence with some very tiny updates about the Cloud Foundry Day schedule. So if folks have not been able to peruse that, there's a keynote that we start off with. The keynote is by Catherine McGarvey, who is on the Cloud Foundry governing board, and she also happens to be like the chair of the board. So it's going to be very interesting to hear from her in terms of what her vision is for the community, for the various projects, and for PaaS in general, I guess. And then the next talk is by Julian. Julian again comes with like a lot of experience with Cloud Foundry, um, as users, as consumers, as contributors, and things like that. So again, that's going to be an interesting talk for me because it encompasses sort of what was his experience with like the older Cloud Foundry stuff, how his experience has been with Bosch and things like that, and also goes on to share what he looks forward to. And then there's like I mentioned, a few combinations of um, Bosch based and Paketo and Carifi and all of these different areas in general. And there's also a talk by Eric, who's part of our TOC and who I like to call like the Gandalf of the CF community because he's been here forever, I guess. And then the last sort of segment is like a bunch of lightning talks. So we have 4, I think, maybe 5, that all go into different aspects of the community, some of the work we've been doing in updating our infrastructure for more efficiency and better costs and things like that. So yeah, that's I just thought I'll insert a brief advertisement of sorts for for what the various talks are. Jintu, want to sharing the screen and see if that works again? Perfect. Yeah, go for it. I'll shut up now.
Jintu, you are on mute.
Can you hear me now?
Yeah, it's clear.
Yeah. Yeah. So coming to Interoperator, the overview of Interoperator. Why we need Interoperator comes from why we there are if you look into the Kubernetes world, whenever you wanted to create a service, so you will be mostly going for Kubernetes operator approach. So operator is a combination of set of custom resources in Kubernetes and custom controllers associated with it, which will be watching your resources and make sure that your resources will reach its desired state from the actual state. So if you look into the Kubernetes hub, Kubernetes operator hub, you can see a lot of operators are available. So let's say as a service provider, you wanted to make your Kubernetes operator or your service, which is being hosted in Kubernetes as OSB compliant, then if you have to do it, so you can basically make use of Interoperator. So basically what we will be doing is we will be exposing, we will be mapping the OSP APIs with um, Kubernetes custom resources of that operator. So that's what basically Interoperator does. So Interoperator, you can consider this as a OSB adapter, which will make your service or the Kubernetes operator an OSP compliant. And so if you do a multi-cluster setup of our Interoperator, so basically if you install Interoperator in one cluster, it will help you to provision instances in multiple clusters. So that is also one of the important features of Interoperator, which will come through in the later slides. So how we can make use of in the CF world is that, like, let's say you have a, sorry for the disturbance. So let's say you have a service in Kubernetes. So mostly it will be an operator, and you wanted to be make it compliant, OSP compliant, so that you can get use in the CF. So like only when it is OSP compliant, only you will be able to register with the CF and make use of it in Cloud Foundry. So for that, you can install Interoperator, and then Interoperator will be the front end part, which will be serving your um, OSB request, and will map it to the custom resource of the operator. So this is what Interoperator is all about. This is the summary. And coming to Interoperator specific, some architecture details. So Interoperator has some specific custom resources created in Kubernetes. So first one is SF service. So this is equivalent to the OSB service that we have. So so your operator will be providing some services, right? And so those services needs to be registered in Interoperator as SF service. And similarly, like all the plans that are available that are available in the service, like there will be some services plans that will be supported by your service. So that plans needs to be registered as SF plan in Interoperator. So like your operator can provide multiple services. So let's take a very simple example that, okay, you are have a Postgres operator, which will provide you Postgres as a service, and it have multiple plans, like a standard plan and a premium plan. Premium plan. And so in that case, your service, as a service, needs to be corresponding to your Postgres service, and you are for the plans, premium and the standard. So you need to register that as an SF plan in Interoperator. Then comes to SF clusters. So SF clusters are the list of clusters that you want Interoperator to manage. Or in other words, you can even say that in the clusters in which you wanted to provision your service. So that needs to be added, register as SF cluster. So let's say you wanted to provision your service in 5 clusters. Each 5 clusters, you need to have a SF clusters here. And then coming to as a service instance and as a service binding. So whenever you have when an OSB provision request come, the interoperator will records all the information regarding that call in as a service instance. And similarly, whenever a provision bind request come, all the details are captured in as a service binding. So these are the interoperator specific customs here that you'll be seeing. Then coming to the major components that interoperator have is first one is broker. So broker will be is your the adapter part, which will be converting your OSB call into custom resource. So so broker will be serving your API request, and it will capture, like when it's a provision call, it will capture all the information as in the CR as a service instance. And similarly for whenever a binding call comes, the broker will capture all data as part of as a service binding. Yeah, that's what the mainly what broker does. And whenever like a V2 catalog call of like OSP call comes, like it will be just reading all the information that are available in SS service and SF plan, and then it will map it to the OSB catalog and will provide the information. Then comes Protioner part. So Protioner, you can, that is another custom. It is the one of the custom controller we have, which will make sure that, okay, your SS service binding or that SS service instance here is getting mapped to corresponding resource in the operator. So that is what Protioner does. Then you have scheduler. So scheduler is also the another custom controller which we have, which will decides in which cluster we are going to provision the service. So let's say like as part of SF cluster CR, you will be listing more than, you can have one or more SF cluster in your interoperator. So when you have more than one cluster, so in each cluster, this instance service needs to be provided. That will be decided by the scheduler component. And the multi-cluster deployer is the component that manages your clusters, which are listed as part of SF cluster CR. So this is the basic overview about interoperator and interoperator components. And next is like, how can you make use of interoperator and make your Kubernetes operator and OSP compliant one? So first is that you have to identify the clusters where you wanted to provide your service, and you have to install your service operator there. So right now, interoperator doesn't take care of installation of service operator, so that needs to be done. Then if you have more than one cluster, you have to select one of the cluster as primary cluster, and then as part of step 3, like we will be installing interoperator only in the primary cluster. That will be the where the main interoperator components will get deployed. And then comes application of like registration of SF cluster, SF service, and SF plan. So which are clusters you wanted, which are clusters you have installed service operator, those information needs to be passed to interoperator through SF cluster. And what all are the services and the plans that you provide as part of this operator that you will be registering as part of SS service and SF plan. So these 5 steps will make your operator OSP compliant. So I will go through some scenarios to will get a better understanding about how you can set up interoperator and make your operator an OSP compliant broker. So in case of a single cluster, so here you only have one cluster and you wanted to provision your service here, and that means that you will be installing interoperator also in the same cluster. So as per our setup guide, like you have like so basically like you have to install service operator your own in the required clusters. So you will be installing service operator first. So since we only have one cluster, so this will act as your primary cluster. So then you will be installing interoperator in this cluster. As interoperator have 4 components, but as part of initial installation, we will be only deploying 3 components of interoperator, which are broker, multi-cluster deployer, and scheduler. And so coming to the next step, you have to apply SF cluster CRs. So here you wanted to provision your service in demo cluster. So the SF cluster CR corresponding to demo cluster needs to be applied. Okay, though when that happens, the multi-cluster deployer, which watches on your all the clusters that interoperator manages, interoperator have. So this is already watching on your SF cluster. So SF cluster will create the provisioner component here. So it's the duty of, or you can say like the provisioner is being managed by multi-cluster component. And then you have to apply your SF service and SF plans here to make the setup ready. So this is how in the case of single cluster deployment. And coming to a multi-cluster scenario. So here I'm taking 3 clusters, demo 1, sister 1, and sister 2. You wanted to provide your service in all these 3 clusters. So in that case, your first step will be is to install your service operator in all these 3 clusters first. Then you have to decide one cluster as your primary cluster. And so that will be like right now I'm decide to take demo as my primary cluster. So here I will be installing interoperator. So interoperator will only deploy the broker, multi-cluster deployer, and scheduler components. Then we have to apply the SF cluster CRs. So here you wanted to provide service in demo cluster, sister 1 cluster, and sister 2. So the CR corresponding to these 3 clusters needs to be applied. Once you apply that, so a provisioner will be created, and like all the CRs that are part of Interoperator will be copied to the sister clusters as well by Interoperator. This is the job of multi-cluster. So multi-cluster deployer is the one which will be managing your all the clusters. So what all are like taking care of provisioner, deployment, and installation of provisioner, and like copying your Interoperator CRs and everything will be taken care by multi-cluster. Then you have to apply your SS service and SF plan. So even this also will get copied to sister clusters by in multi-cluster deployer. So this will make your setup ready. So this is about multi-cluster deployment. So I wanted to bring you one more scenario in multi-cluster deployment. So here also you have 3 clusters, demo cluster, sister 1 and sister 2 cluster. But in this case, in this scenario, you wanted to deploy your, you wanted to provide your service only on sister 1 and sister 2 cluster only. And you wanted to install your interoperator in demo 1 cluster. So this will serve as the primary cluster, and you need to provision your services in sister 1 and sister 2. So let's see how we'll be doing that. So here, as part of first step, you have to install service operated on required clusters. As we have decided that we need to provide service only in sister 1 and sister 2, we have to install service operator only in these 2 clusters. In demo 1, we don't need to install it. So we need to select one cluster as primary cluster. So for us, it is demo 1. So we will be installing Interoperator in here. So it will deploy Interoperator. Then we have to apply the SF cluster. So in this scenario, you need to provide, you only wanted to provision your services only in sister 1 and sister 2. So only you need to provide CRs corresponding to sister 1 and sister 2 to the Interoperator. So once you apply that, then MCD will create provisioner only in sister 1 and sister 2. In the last scenario, you have seen that, okay, like we have been creating provisioner in the demo 1 cluster as well. So here we are not doing that because like we only applied cluster SF cluster CRs for sister 1 and sister 2. And it will propagate all the Interoperator CRs as well. Yeah, that will be taken care by in multi-cluster deployer component. Then you will be applying SF service and SF plan, which will make your setup ready. So, so these are the scenarios. I will just go through how the service portioning flow works. So here, let's say you have you have done your setup. So here you have 3 clusters and demo sister 1 and sister 2. And your demo is your primary cluster, and you have done every setup done. Now let's say like you are getting an OSB request, OSB portion request from once you register your broker, you are getting an portion request. So what happens is once you get the request, your broker component will be the one who will be serving that request. It will create a CR called SS service instance, and all the details regarding that call will be captured in this CR. So that will be done by broker. Then the broker part is done. So next, what happens is scheduler comes into picture. Scheduler will decide, like identify in which cluster we needs to install this service. So let's say like it decided to take, as per its algorithm, it decided to take sister 1 cluster. So in that case, what it does is that it will decide on the cluster. So once it decide on the cluster, it will update the SS service instance with the cluster ID. So once the cluster ID is set, MCD will comes into picture. And what MCD does is it will propagate this SS service instance to the to the required cluster. So in our case, it is sister 1 cluster. So it will copy your SS service instance to there. That then MCD has done its job. Now provisioner component comes into picture. So provisioner understand that a new SS service instance been created. It is watching on it. So the provisioner is the one which will be copying your just a minute. Yeah. Okay, so copying your SS service instance, and it will look into your SS service, the service and the plans that you provide, and based upon that, it will convert your SS service instance into. Okay, so it will convert into your SS service instance into service instance. Yeah, so this is what Interoperator does. Now you have created the custom resource in which the service operator works. Now the service operator will take care of the life cycle of that one. Yeah. Like we have one more field called a state, which will decide upon like whether that instance creation has succeeded, failed, or which like what is the state right now? Is it progress or not? And once the service operator take care of its job, like let's say it's a creation is what they have to take care. So once it's done, so we have a multi-cluster deployer, which is watching on cluster and all the CRs. So it will identify that and it will update the state first in sister cluster one first, then it will propagate that information to the primary cluster. So this all will be the part of that managing the clusters, and like what all are the updation happening on the SS service instance will be taken care by multi-cluster deployer. So this is how the provisioning flow works. So similarly, for binding flow, similar approach. Whenever a binding request comes, broker will be creating an SS service binding with all the information. And since like we already then the MCD will identify like in which cluster it is already deployed, and it will propagate that SS service binding to the corresponding cluster. And then in provisioner will kick in, and the provisioner will actually will convert this SS service binding CR to service binding CR, so that service operator can take care of creationing of the binding. So yeah, that's all about a binding flow as well. Um, yeah, so now we will go through the demo and understand like how interoperator works. Anu will help you. I will hand over to Anu.
Thanks, Jintu. Thanks for the explanation. I think then I am jumping to the demo. Uh, so uh, uh, There's the share screen. Okay, got it. Uh, uh, Please let me know if the screen is visible. I have a terminal open.
Yes, it is
Yeah, no,
visible.
you're good.
Thank you. Thank you. So today, as Jintu has explained, we can choose any operator from this. So we have a very big wealthy number of operators, Kubernetes operators in the operator hub. So if you come to the operator hub, we can see that there are a lot of operators that is now listed here. So it's almost 270 operators. And so today we will, as an example, we will be choosing the Postgres operator. So we like databases, so we are picking this operator and trying to make this operator OSB compliant, connecting this operator to our Cloud Foundry environment. So this, as of now, this is this operator is by it's an open source operator, Postgres operator by our Zalando. And here is the GitHub page where there is a good wealth of information and documentation about this operator. So I already installed Zalando in my cluster, Kubernetes cluster. The cluster name is demo. And I can see that the Zalando operator code is healthy and running. So the next step is, so from the documentation, I figured that we can create a Postgres pod with one of the examples. So I have an example from Zalando, that is, if we create a YAML, if we apply this YAML with kind as Postgres SQL, the Zalando knows this because this is the one that Zalando is listening on. Zalando operator provides this kind, and if we install this, the documentation says that we will get a Zalando port. We will get a Postgres port. Let's try this out. So without this is before integrating Interoperator. So usually, if someone wants to create a Postgres pod, Postgres deployment, so what they need to do is let's go to the document. Uh, they need to create using this example YAML that Zalando has provided. Postgres operator has provided. So okay, sorry. I am not in the right location. PWD. Okay. Sorry about that. Copying the command. Applying. Yeah, applied. So now if I go to the cluster, so this is the view of the cluster. Just move this. Yeah. So this is a tool called K9s, which is very it gives a very good graphical representation of the pods in the Kubernetes cluster or the resources in the Kubernetes cluster. So we can see that now two we now got a Postgres deployment or pods. So if we check deployments here, we have a Postgres deployment in the default namespace, or it's a stateful set. Sorry, let's go to pod itself. Yeah, so we have two ports, and if we check this Postgres SQL, yeah, we have one instance of this Postgres SQL kind where we have this version ports and the GB. So this is the contents. So the size, version, and CPU. I think only the size is mentioned. So this is the uh, CR that we need to create. But now we need to integrate. We are now planning to integrate this to our Cloud Foundry environment. So for that, as we seen in the presentation, the steps that we need to do are first we need to install the service operator in clusters. Yes, we have done that. Then we need to select one cluster as primary. Yes, I have selected one cluster as primary. Then I need to install Interoperator in the primary cluster, which is fairly simple. We can install Interoperator using the Helm chart. So we have the Helm charts available. Running this command, Helm install will install Interoperator. So the one, so if you want, you need to give the ingress URL so that we can create an ingress, and that can be connected to the CF environment. Rest the command is very simple. Then next step. So we are going to we have already so now the interoperator is installed and it's ready. Let's go to our CF. So now I have, if I check the CF services, there are no service instances running created in this phase space, and we can see that we have a service broker with name. This is our service broker installed in this cluster. So let's see these clusters in the interoperator namespace. So if I go to interoperator namespace and deployments, we can see all the components of interoperator are up and running. Now let's do our CF calls. So now I'm going to, so let's see the services in CF marketplace. There is a Postgres native service. Let's create a service using our CF commands. CF create service. I am creating a service by the name demo1. Now we can see that the service creation is in progress. It is ongoing. So let's go to our demo one cluster and see what is happening. So let's go to demo one cluster and list the ports or PostgreSQL kind in all namespaces. Yeah, we can see that there is one new PostgreSQL kind is created. Uh, so now we see that it has a specific name, CF called the UUID. So this UUID is something that is the UUID of the CF service that we have now just now created, and it's creation in progress. And if you go to here, let's list the ports. Ports. So here we see that. So here we can see that there are two ports. These are Postgres ports, which has a name CF cap call, and it is now created. So just like how we created the ports in default namespace with the YAML file example of Postgres operator. Now we are doing it from our CF. So that means we are able to integrate the Postgres operator to our CF environment. Let's go back to CF CLI. Let's check the state. Create succeeded. Yeah, we are good. Similarly, we can also create a binding. Let's come and I'm going to create a binding for demo one, named demo one key. Here this, CF, I'm creating a service key for this service instance with the name demo one. Let's see the service key. Is key demo one. We have the URI of the Postgres, so directly we can use this to connect. Let's remove this. Yeah. So now using the CF CLI, so using the CF, so now we have the connection between the Kubernetes cluster and CF, and even we can do the service provisioning, we can do the service binding, and we can also do the other operation, like we can also delete the binding, deprovision the instance, and so how this is happening. So I also can also do the catalog call from maybe a browser or even Postman. So all the OSP calls now works. So I did a catalog call, V2 catalog call. So we can see the catalog. It's showing some information about the service and plan. Now let's see how we are able to achieve this using Interoperator. So so this is done with the help of SF plan and SF service. So if we come here, we have something called SF service and SF plan. So SF service has some information about, we are giving some metadata information, like what is the name of the service, should be the name is Postgres native, and tag should be Zalando, and some information, documentation URL. So these things will be coming up in our catalog code. And SF plan is the tricky part, where we have some placeholders like we have a session called templates, where we have something called actions. So we have action for sources, status, provision. This one is interesting. So this action states that what should we do when there is a provision code. So here it says that so we are supposed to create a service. So we are supposed to create a resource in Kubernetes with this details. So here uh, the type of the resource should be of kind Postgres, and there are some placeholders. That is like the name we can be, we are using a name prefix, and then instance ID. Instance ID is something that we are getting for, we are passing when we do the Postgres, when we do the provisioning code from CF. So the CF is passing this instance ID to us, and then some metadata information, and then uh, uh, information about CPU limits. So how we are creating this provision field in SF plan based on the example that we got from our Postgres operator. So we know that if we create a resource, if we apply this custom resource by the name kind, and with these details, Zalander's operator is going to create a Postgres for us. So we are translating that information to our SF plan here. So when a provision code comes, Interoperator now knows that, okay, what needs to be done. Interoperator now knows that it needs to create a resource with this information. And then similarly, we have something called action bind, where we say what should be done, what should we do for the bind operation. So here we are creating a resource, or we are updating the same Postgres resource, and with there with some details about the user. So these two, SF service and SF plan. SF plan is the main part where we can uh, make Interoperator understand that what should be done next to create this instance here. So that's the integration part. So now let's go to the next part, that is multi-cluster setup. Now we have so now, as we discussed before, uh, we can have all the service instances in a single cluster. So we can integrate the interoperator with any number of service instances. So now I have Postgres operator, maybe there is an Redis operator. So all these services and plans will be visible in the catalog. And we can use a single interoperator to serve all these Kubernetes operators, any the DB anything. But then it might be beneficial to have the interoperator in one cluster as a control plane, and then we can have the other operators in different clusters, Kubernetes clusters itself. Or maybe there is higher load, so we need to have we might it might be beneficial to have many different clusters, so that the Kubernetes API server is not loaded. So now I am going to apply a cluster to the interoperator. So for that, what we need to do is we have one resource called SF cluster. So what does this SF cluster has? This is SF cluster. So it has a secret where we store the kube config, and then we are explaining about how where to get the secret. It's a small configuration. Okay, let's go to our, so I'm going to apply this to the details of the second sister cluster to interoperator. Yeah, it's configured. Yeah, already. Yeah, so now if I do kubectl get SF clusters in interoperator namespace. Okay. About that. Now if I go to the sister cluster and I try to get ports in interoperator namespace, now we can see that when we told interoperator that there is a new cluster, interoperator is creating a provisioner in the cluster. So that provisioner is nothing but an agent of interoperator, which helps in deploying in the services here in this cluster. So this cluster also has the Salando operator. Let's see if the Salando is up here. The Postgres operator is for up here. So how to check that? Yeah, here. So uh, oh, sorry. Yeah, it is running. So now I go to my CFCLI. I'm going to create a second instance. So where is the command? Creation in progress. So if I go to the second cluster and list the ports or namespaces, it will take some time, but yeah, we'll be creating soon. Oh, okay. The first, yeah. So I did not create, not created the SF cluster in the right namespace. So yeah, so the idea is, so now if I have this new cluster, the SF service will be created in the second cluster. So yeah, so that is also done. So now we can proceed with deletion and removing of the unbinding key. So now we covered all these steps. So first we need to install the service operators in the cluster. We need to select one cluster primary and then install and operator in the primary cluster, and then apply SF service, SF cluster, and apply SF service and plan. And now we are good to go. I think that's all. Uh, um, any questions? If not, then um, I I can stop sharing and I'll I'm handing over to Jintu.
Yeah, so that's all about interoperator, and so I will share this. We have interoperator as part of Service Fabric broker. Um, yeah. So and documentation is also available in the Service Fabric broker. If you go through documentation, a lot of about like how to make use of interoperator. the basic details and what all are the main important features that is available in Interoperator. You will see, and if like plenty of documents to implement it in your own clusters. And roadmap is also available. It's available in our wiki page. Yeah. So you can contact us on Service Fabric channel in Slack in case of any queries. Yeah, that's all. I'll hand over to Ram.
Thanks,
Any
Jitin.
questions?
Thanks, Anoop.
Sorry.
Yeah.
Hey,
Uh,
I was just wondering, so obviously the focus of the foundation is Queryfee right now. Not to make other projects feel stepmotherly love or anything, but um, i- how do we um, connect this, or how does this, work with Queryfee? What would be steps to take where we can demonstrate both Interoperator and Queryfee together? I mean, if you could just give an idea, I think people would be interested in exploring that direction.
okay. I believe with Coryphy also we need an we need an OSP compliant broker for any of these Kubernetes operators. So we can connect. So we can use the interoperator OSP capabilities to connect. So now we have connected to CF environment. So rather than that, we can directly connect it to Coryphy, if I'm not wrong. And then the developers don't need to, the service operators who already have a Kubernetes operator, they don't need to develop a new OSP broker. They can readily use this interoperator. But I think, Ram, that's a good point. I think I need to explore more about how we can integrate these two both. Maybe that's a homework for me.
Yeah, homework for us, I guess.
Yeah.
All right, if there's no
Yeah.
questions, I think we can call it close. Thank you so much, Anoop. Thank you
Yeah.
so much, Jitin.
Yeah. Thank you, Ram. Thank you for this opportunity. And I think interoperator. So now we have uh, it helps in bridging the gap between Cloud Foundry and Kubernetes. So we are experiencing it in our organization at SAP. So we have a login service which has an operator. It uses an open search logging ELK stack. Then they have their own operators, and with Interoperator we are able to seamlessly connect it to our Cloud Foundry environments. And then and the scale is also very large, so almost entire organization uses these operators for creating the dashboards, and it all flows to Interoperator. It is handling very well. So I think it yeah.
Cool. Again, thank you very much for the presentation. And yeah, I look forward to seeing you all on other community calls and things. And well, after CF Day, I guess. Thanks, everyone.
Thank you.
Bye-bye.
Bye bye.
Yeah. Thank you, Ram. Thank you all. Bye.